Hello, my name is Ardi and we are going to solve problem 2.67 from Hambley's book. So the question is use mass current analysis to find the value of I1. I1 is here. So maybe let's do the loop first. Let's name this loop here is I1. So it is exactly the same as I1 here. But we have other loops which is on this side here and also on this side, but I think I will follow the direction of that arrow here. So we will have this, but remember that this is the mass current here is the same as the current source here, so this is 1 ampere while this is 2 ampere. Okay, what we need to do is just use KVL in loop I1. Okay, and I think we only have one equation from here, so let's do that. KVL at loop I1. KVL said that the sum of the voltage in a loop will equal to 0. This is what KVL said. Okay, let's start from this 10 ohm resistor. Okay, that 10 ohm resistor, remember that this is a resistance. To get a voltage, we need to multiply it by a current. However, there is only one current that passes through this 10 ohm resistor, which is I1. Okay, so I will have I1 here. So this is for the 10 ohm resistor here. So maybe let's highlight that because we already done this. And now let's move on to the 5 ohm resistor. So I will have 5. Again, this 5 is a resistance. We need to multiply it by a current to get it into voltage. However, we are now working at loop I1, so we need to see it from the perspective of I1 here. So we will have I1 here, but there also this 2 ampere current that pass through this 5 ohm resistor. So the direction here is the same as I1. So the sign will be positive here. So I will have plus 2 ampere. Because I1 and 2 ampere flowing to the same direction, which is the bottom, right? And then let's move on to the 20 ohm resistor, but let's highlight this. Okay, now let's do 10. So I'll have plus 10 there. And again, because we are working on I1, everything is on the perspective of I1. So I will have I1 here. But then this 1 ampere current is flowing to the opposite direction. Because if we see here, I1 is going up while this 1 ampere current is going down. So they flow to the opposite direction. So I will have I1 minus 1. Okay, and this, that is not 10 but 20, right? So this will be 20. So this is 20 ohm. Okay, let's highlight that. So we'll have that 20. Okay, so we'll have 1, 2, 3, and also we have 1, 2, and 3. All of that will equal to 0. Okay, maybe let's do some algebra here. So we will have 10I1 plus, let's distribute this. So I will have 5I1 here. And then 5 multiplied by 2, that is 10. So I will have plus 10 here. And then plus 20 multiplied by I1. So I'll have 20I1. And then 20 multiplied by minus 1. So I will have minus 20. All of that will equal to 0. And okay, we will have 10 plus 5. That will be 15. 15 plus 20. 15 plus 20. That will be 35. right? So I will have 35 I1. And then we will have 10 minus 20. So I will have minus 10. All of that will equal to 0. Okay, so now I will have 35 I1 is equal to 10. But then I1 is 10 divided by 35. The unit here is ampere, and I think we can simplify this fraction, right? Let's divide this by 5, so I will get 2, and let's divide this by 5, we also get 7. So we will have I1 is 2 over 7 ampere. Okay, we can stop here, but I want to know the decimal one. Let's set up our calculator. So what is 2 divided by 7? Okay, yeah, 2 over 7. We already know that. So we need to push this SD button to convert it into decimal. So we will have that one. Oh, the brackets means that it will repeat it. So 285714. The next one will be 285714 also. So I just want to write 5 significant number. So we will have 0.285, and then what is it? 714. 714, and the unit is ampere. But we can also write it in milliampere. So I1 is equal to, let's multiply this by 1000. 1, 2, 3. So I will have 285.714. And the unit here will be milliampere. Okay, and I think that is the final result of the problem 2.67. We already used mass current analysis, and we got the results here. Let's highlight the result. And I think that's all for this problem. Let me know if I made any mistakes in my calculation. See you in the next video. Bye bye.